Hey, seventh graders, welcome back. It is week 7. It is May 13th, and I'm really excited to dive into today's lesson. A couple of housekeeping reminders before we get started. We are in our final week and a half left of 7th grade, wild, and so our schedule is changing a little bit. So for office hours or for any other help that you need, you can always continue to send me an email or give me a phone call if you need a little bit of help on your assignment. As far as office hours, please just stay tuned to the post that Ms. Russell is putting in Google Classroom that has some updated times or updated availability for office hours. So in our final week and a half, we're doing things like getting report cards out and calling all families. So our schedule is shifting up a little bit so that Ms. Russell has time to do all of those end of the year school jobs and so that I have time to do all of those too. So just so you know, things are changing a little bit in terms of our schedule. You'll still see your lessons here. I am posting them at 10 a.m. now to give you a little bit of extra time to complete them. But if you need any extra help, you can always send me an email and I can get back to you when I can, or just look out for that new time of office hours, okay? It is on, tomorrow is our last quiz of 7th grade math. Yay! So what I want to do today is two things. One, we're going to review a couple of concepts that I know will be on the quiz that I want you to be super prepared for. And the second is we're going to find the volume of prisms today, including cylinders. I'm excited to dive into those two things, specifically really looking for your engagement in the video for these review and quiz prep questions. I'll be able to tell based on your quiz results who is taking careful notes today. So make sure you have your notes ready to go for today. In fact, here's what your notes should look like. This label again will help you when you're taking your quiz and you see, you see a question that says find the actual area. The one that we do right here, first thing, is going to help you on that question. When we look at a composite area question, it's one that we'll look at today is one just like the one you'll see on your quiz tomorrow. So again, make sure you have these notes and they're labeled and then stored somewhere safely. Additionally, we're going to look at volume of prisms today. Of course, that will also be on your quiz, and this is the last one. So I can't wait to see you guys crush it. Alrighty, we are going to start by reviewing something we did the other day, a couple days ago, called finding the actual area. We looked at scale drawings and we used scale factors to represent something in a small drawing that actually is something in real life. Okay, so I want to read this story together and then I want to show you just a way to solve it really quickly and easily. Here we go. The scale on a map shows that 1 unit is equal to 4 feet in real life. That is the scale. That is that? Yes. A rectangular garden plot is shown in the scale drawing below. Each square on the grid represents 1 unit. What is the area of the actual garden? Okay, the big thing we talked about in the video a couple days ago is because of what we know about the scale factor for length and area being different, like 2 times longer side lengths means 4 times bigger area, that changes, and that's tricky to remember. And one thing you can do so that you don't need to remember that is to find the new lengths first and then find the area of that new object, okay? So let's go ahead and set up our notes. And I want to do this in a way that is so that you can review a little bit. So let's go ahead and call this number 1. And go ahead and label it find actual area from scale drawing. Find actual area from scale drawing. And let's go ahead and put that scale drawing on our paper. It was 3 units by 4 units. Okay, let's go ahead and draw that in. And 3 and 4 were not given to me in the question. but I had to count the boxes to get them. I have graph paper, and if you don't have graph paper, it's totally fine. Let's just label this 3 units and 4 units. Okay. And it also gave me the scale in the question, and that's also something I want to write down. It says 1 unit is equal to 4 feet in real life. Okay, so I've got 1 unit in each of these little boxes. I know that 1 unit equals 4 feet. Okay, so what are my steps? Let's stepify this a little bit, break it down. The first thing that I want to do is I want to convert my lengths. Right now they're given in units in this drawing. What I want to do is find out what are the lengths in real life, remembering that 1 unit is worth 4 feet in real life. So the first thing I'm going to do is convert the lengths. The second thing I'm going to do is what? The second thing I'm going to do is find area of actual. When I say actual, I mean the thing in real life. So this real garden that is represented by this tiny picture, but of course is much bigger in real life. All right, so make sure your paper looks like mine. If you need another moment, pause the video. When we did this the first time, I set up a ratio table and I had units and feet, or I had centimeters and yards, or whatever it was. This time I'm going to try a different strategy. I'm going to go ahead and just update the labels on my picture with what they equal in feet. So if 1 unit is 4 feet, what is 3 units? If 1 unit is 4 feet, then 3 units is 12 feet. Is this actually 12 feet long? Not in the picture. In the picture, of course, 12 feet would be much bigger, the size of a big garden plot, right? But I can represent it here. 3 units will be equal to 12 feet. I just need to imagine that it gets bigger, right? What would 4 units be equal to? Yes, 4 units would be equal to 16 feet. So my actual garden plot is 12 feet by 16 feet, okay? I have converted the lengths. Now I'm gonna find the area of the actual. In real life, the actual amount is measured in feet. So I'm gonna use this measurement here. Let's go ahead and multiply 12 by 16. Because the area of a rectangle is base times height, and I get 192. So I'm going to go ahead and label the inside 192 feet squared. That's it. That is the area of the actual garden plot. Okay. Now the area of the drawing itself is 3 times 4, 12 square units. Of course, I'm not interested in the area of the drawing, and this question is asking me for the actual. Okay. Awesome. Let's go ahead and pause here. Make sure you have the answer. You have this annotated diagram, you have the scale, and you have the steps on your paper. Awesome. I want you to go ahead and enter in your Google form number 1 now. I want you to select the steps that we used to answer this question. Do that now. Awesome. So you'll see a question just like that on your quiz tomorrow. So make sure your notes look awesome. We're going to move on to a second question. This is a composite area question. Composite just means made up of shapes. In this case, it means made up of shapes. So I see here a rectangle and I see, what is this? This is called a semicircle. This is called a, yes, it's just a half circle. That's all it is. So we're going to find the area of this whole composite figure, this whole shaded area, by breaking it into its pieces. Okay, find the area of the figure, round your answer to the nearest tenth. Let's do it. We're going to go ahead and draw it. But before I start drawing, let's go ahead and label number 2. This is a composite area with semicircle. We didn't do one of these in our lesson a couple days ago, but it is part of the standard in 7th grade math. So it is required that you're able to do it, and it'll be on your quiz. So let's do a little bit of practice with it. Of course, we did this during the regular school year, but I want to make sure we get to review again. All right, so let's draw it. There was a rectangular piece, looks something like this. And then there was a semicircle connected to it. So if I want to find the composite area, I'm going to find the area of each piece separately because there's no formula for a shape that looks like this. This is a wonky shape. I'm going to find the area of the rectangle and the semicircle, and then I'm going to add them together. Okay? Let's just write those dimensions down too so we can label our picture. Let's see, I had a base of 12 and a height of 4, and then this little section was 3. All right, my drawing is not to scale, that's okay. All right, let's go ahead and find area of the rectangle. This is the easy part. The rectangle has a base of 12 and a height of 4. I know the area of a rectangle is found by multiplying the base and height. 12 times 4 is 48. Let's see, I don't think I was given units. Let me double check. Yep, no units. So we're just going to call that units squared. Okay, and then this is the fun part, the area of the semicircle. Okay, go ahead and label area of semicircle. Why are we labeling? We're labeling so that when you look back at your work, you know exactly where to look for the kind of question you're working on. So if you get to your quiz or if you get to your independent practice and you need to find the area of a semicircle, you know exactly where to look. Otherwise, if you just have the algebra, it gets really confusing and your work isn't very helpful to you. So if you're going to write anything at all, I think it should be labeled. I know the area of a regular circle, a full circle, is pi r squared. That's a formula you need to know. Write it on your paper. But this is a semicircle. It's half a circle. So I don't want to find the area of the full circle. I want to find half of this. So I'm going to take pi r squared. I'm going to adjust my formula and divide that by 2. Why do I divide by 2? Yes, I divide by 2 because it's half of a circle. So I want to take the area of a circle and cut it in half, split it into 2. All right, let's rock it out. Do we know what pi should be? Yeah, the problem said round to the nearest tenth. So I'm going to approximate pi with 3 1400ths times, I need to know the radius. Well, the radius in this diagram is here. It's half of it's from the center of the circle to the outside, right? I'm not given that measurement, but I can figure it out, no problem. If I know that this is 12 and this is 3, what must this be? Yes, 9, right? This part right here is 9. So what's the radius? Yeah, my diameter is 9. My radius must be half of that, 4.5. All right, so let's go ahead and fill that in. Times 4.5 squared. Don't forget divided by 2 because I'm finding the area of a semicircle. Okay, it's calculator time. I'm going to do my exponent first. I don't know what 4.5 squared is, but I know my calculator does. So 4.5 squared means 4.5 times 4.5, and I get 20.25. Okay, I'm going to take that now and I'm going to multiply it by 3.14. All right, let me update my paper. The product here was 63.585. And now I'm going to divide it by 2. This would be the area of the complete circle. Of course, I just want half a circle. So divided by 2 equals 31.7925. All right. So the answer said round, or the question rather said round to the nearest 10th. So I'm going to take this amount and I'm going to add it to my rectangle. So my third step here would be to add. So my area of the rectangle, 48, plus I'm going to go ahead and round off the area of my semicircle to 31.8. 79.8, I need a unit. Units squared because area. In area, we measure that in square units. Awesome. So I've got a lot of work here. Take a moment to summarize to yourself. It's okay to talk to yourself. I literally do it all day. Summarize to yourself, how did we find the area of the composite figure? Yep, the trickiest part of this is finding the area of the semicircle. I believe we all know how to find the area of a rectangle. We all know we need to add the pieces together, the area of the pieces together. The one thing that I introduced in this example problem is how to find the area of a semicircle, okay? The other thing to keep in mind is that sometimes you're given the diameter, but the formula for area of a circle requires the radius. So you've got to be able to go from diameter to radius, okay? Awesome. I'd love to get an email from you if you're wanting a little bit more practice or a little bit of clarification on this skill. I'd love to give you that. But if you feel good to go, we're going to move on to the next question. All right. We are going to pause here and let's enter into our Google form for number 2. I want you to enter, how do you find the area of a semicircle? How do you find the area of a semicircle? Okay. Awesome. Let's go ahead and move on to the next one. So today, that was all review, right? This is still review, but it's review from the very beginning of the school year when we did volume of prisms. So let's go ahead and review. Prisms have 2 bases that are identical. Here is a triangular prism. So it's a 3D solid, and it has a base that's a triangle, and it has another identical base that's a triangle. This one is shown that purple face on the top and bottom, those are called the bases. This is a pentagonal prism, say that. Yes, because its bases are identical pentagons. And this is a rectangular prism, and that's because the bases are identical rectangles. Notice that all the other faces in all of these figures are rectangles. So look at this triangular prism. It has a base that's a triangle, but it has this front face right here that's a rectangle. And then it has 2 more on the other side. Okay. When I want to find the volume of a prism, we talked about in class this year that the volume of prisms can be found with this formula. V equals BH, where B is the area of the base and where H is the height of the prism. So for this triangular prism, the base is shown here in yellow, or this bottom green triangular face. If I find the area of that triangle and I multiply it by the height of the prism, then I get the volume. Same thing for a rectangular prism. If I find the area of this yellow rectangle or the one on the bottom, I find the area of that rectangle and I multiply it by the height of the prism, I get the volume. Note that sometimes we knock prisms over on their side. 1, so that we can become really flexible with our math work, but 2, sometimes what we want to find the volume of actually looks like this. Like this looks to me like a tent, right? A tent is not stood up on its triangular base. So we've got to kind of define the prism height a little bit differently. And what we decided this year is to define the prism height as the distance between the bases, okay? So take a look. here is the base of my rectangular prism. I'm looking at the bottom here, and the height is the distance between those two identical rectangles. In this triangular prism, the bases are triangles. The bases are? Yes. And the prism height is the distance between those triangles. So in this case, the triangles go front to back, and the prism height is actually this length right here. Even though this height isn't up and down, it is still the prism height because it is the distance between the bases. Same thing for this cylinder. In a cylinder, the base is a circle. The base is a? Yes. So the prism height is the distance between the two circles. Let's give it a try. Let's find the volume of this triangular prism. I'm going to go ahead and set it up with you, but then I want you to try it on your own. We are going to label number 3, volume of triangular prism. And I'm going to give you the formula. Volume equals the area of the base times the height. Remember that in a triangular prism, the base is a triangle. So here you're going to find the area of the triangle multiplied by the prism's height. Okay. I'm going to give you a little bit of time to work on that. Let's do, gosh, I think we're going to need 2 minutes here. Let's do 2 minutes. Go ahead. So we're just over halfway through our time. Just a reminder that the area of the base, just look at the triangle and go ahead and find the area of the triangle. All right, let's come back together. So a couple of things to point out before we take a look at my work. What is the prism's height? Remember, the prism's height is the distance between the bases. What is the prism's height? Yes, it's 18. The bases are the triangles, and 18 is the distance between those triangles. So this triangular prism is knocked over on its side, but it's still the height, the prism height is still 18, okay? And the base here is a triangle, which has a base of 12 and a height of 7, okay? Let's take a look at my work. I know that capital B means the area of the base, which is a triangle. I went ahead and drew that triangle here. I know the triangle has dimensions of a base of 12 and a height of 7. When I want to find the area of a triangle, I have to use the area of a triangle formula. 1/2 times base times height, or base times height divided by 2 would be fine as well. I know the base of the triangle is 12 and the height of the triangle is 7. When I simplify, I got the area of the base was 42 square yards. We discussed already that the prism's height was 18. So in my volume formula, the area of the base is 42 and the height of the prism is 18. Okay, when I multiplied those, I got 756. And I know I'm in volume gonna give my answer in cubic yards. So that's what this says, 756 yards cubed. All right, volume is tricky for a couple of reasons, but the trickiest thing I think is identifying what the prism height is and identifying what the formula you need to use for the area of the base. Okay, so just a reminder, you should be using your triangle area formula. Awesome, let's go ahead and take a second and enter our answer in for number 3 on your Google form. So just go ahead and write in the answer. Just type the number, not the unit. Excellent. Let's try another one. You'll see a question like this on your independent practice today. This is question 4. This is about the volume of a cylinder. So I'm just labeling my work number 4, volume of cylinder. A cylinder is like a can of soup. That's the shape. All right, what is the volume of a cylinder with a diameter of 20 meters and a height of 4 meters? Okay, I'm going to go ahead and write D equals 20 m, 20 meters, and H equals 4 meters. Check out my answer choices. Do you see how pi is in there? We call this giving our answer in terms of pi, and what it means for us as we start to calculate the volume is that we're not going to use 3.14. We're just going to leave the symbol for pi in there to give us an exact answer, not a rounded answer, okay? So mathematicians who look at our work will know that we are going to leave answer in terms of pi. Mathematicians who look at our work will know what we mean, right? Because mathematicians all over the world use the symbol pi to represent about 3.14, but not exactly 3.14. Okay. So volume of a cylinder, we can use the same formula as volume of a prism. Cylinder is a type of prism that has bases that are circles. So my height was given, my height is 4 meters. And the area of the base is not given, but I know how to figure it out. The area of the base, in this case, is the area of a circle. The area of a circle is pi r squared. Okay, I'm given diameter, you need to use radius. Go ahead and finish solving this one on your own. Let's take 1 minute. Go. Remember to leave your answer in terms of pi. All right, last 20 seconds. Remember, when you leave your answer in terms of pi, just leave the symbol where it is, kind of like you would a variable. Don't use 3.14. All right, I'm excited to review my delightful mathematicians. Here we go. When I find the volume of a cylinder, I know that the base is a circle. I know that to find the area of the circle, I do pi times radius squared. Since the diameter is 20 meters, that means that the radius is 10 meters. So I plugged in 10 for the radius. Pi times 10 squared. Make sure your paper looks like mine. 10 squared is 100, so the area of the circle is pi times 100. I'm not going to plug in 3.14 because my answer should be in terms of pi based on my answer choices. Awesome. So then I am thinking about my area or my volume formula. Volume equals the area of the base, pi times 100. I rewrote that as 100 pi, times the height of the cylinder, or the height of the prism, is 4. When I multiply 100 pi times 4, I get 400 pi cubic meters. Awesome. Go ahead and update your work here if you need to by pausing the video. An awesome job if you got that one on your own. That's a tricky question. You'll see it on your independent practice today to get a little bit of extra practice. So B is correct, 400 pi. All right. Last one we'll do together is a rectangular prism. It says a box is shown below. What is the volume of the box in cubic feet? So this is question 5. I'm just labeling it as a volume of rectangular prism. Volume of rectangular prism. Okay, I'm going to give you just a minute to do this one. Rectangular prisms are a lot easier than triangular and then cylinders. 1 minute, go. Remember to be using your formula for volume of a prism to solve here. Give your answer with the correct unit. All right, let's review our work. I got 24 cubic feet. Is that what you got? Awesome. If you didn't get that, go ahead and pause the video here to check my work. Just a reminder that the base is a rectangle, and to find the area of a rectangle, I multiply its base by its height times the overall height of the prism. Awesome. All right, folks, it is time for your to-do list. Today, I want you to complete your independent practice and your skill builder. Please keep in mind that our schedule's just shifting a little bit to make sure that teachers have time to do all the other end of year things. But check out Ms. Russell's post for updated times, and you'll know exactly what to do. I think that's it. Have an awesome rest of your Wednesday. See you back here tomorrow. Bye.